Yeah. Okay. Unfortunately, we did a lot of good problems before we started recording. That was all part of office hours and stuff. Okay. Um, again, I'm hitting what I consider to be the highlights of chapter 1. Remember, this is all review, at least in my mind. Feel free, please, to always ask questions just like you guys are doing. I'm hitting the highlights. If I don't cover something that you need help on, then for God's sakes, yell and scream at me. Say, hey, wait, I did this problem, or I'm confused, or I need extra help. Okay. I in a classroom, I can look out and I can see whose eyes are rolling up inside their head. I can see who's falling asleep, and I can make fun of you. I can't do that here. So I have to rely on you guys to be honest and say, wait, stop, Foster, I don't get it. Okay. And again, if people put something in the chat, I can't read the chat. I've turned it off. I can't see it. But if there's an important comment in the chat that you guys think I should be looking at, then please stop me and direct me to the chat so I can answer that question. Okay. In chapter 1.3, there are two concepts: the concept of opposite and the concept of absolute value. Okay, two basic concepts. Opposite literally means the opposite of each other on either side of the of 0 on a number line. So if you have a positive a on this side, its opposite would be called negative a, and the key is they're the same distance from 0. They're both the same distance from 0. One's just to the right, one's just to the left. Okay. And so for opposites, we have things like -3 and +3, -5.2 and +5.2. Okay, so those are just opposites. They're on opposite sides of the number line. They're the same distance from 0, but one's on the right side, one's on the left side. That's all we mean by opposites. Okay. There's a rule that we use for adding and subtracting integers. If you have a plus, wrong. If you have a minus b, there's a rule that says we take a, change the minus into a plus, and change this to the opposite of b. Okay, so for example, what if you had -7 minus 9? That always confuses people. They don't know, is the answer 2, -2? Is it 16, -16? So this rule that we have for positive and negative numbers says leave the front number -7, change this to a plus, change the minus to a plus, and change this number to its opposite. Well, what's the opposite of 9? -9. This rule is what we use all the time to add or subtract positive and negative numbers. Okay, when you have a subtract b, you change it to a plus, and you change this to the opposite of b. So -7 subtract 9, because -7 plus the opposite of 9 is -9. Now this problem says, hey, I lost $7 and I lost $9. So altogether, I've lost $16. So that's where we use the concept of opposite when we're adding and subtracting positive and negative numbers. Now, whether or not you actually use it here or you just knew the answer was negative 16 doesn't matter to me at all. Okay, but we do use the concept of opposite in a lot of situations. Now, the next concept is absolute value. Okay, absolute value is denoted by two bars. Okay, straight up and down bars. This is going to be a reoccurring, what can I say? What would be a good word? Bitch? No. Moan? No. Complaint? No. I don't know. Whatever it is for me. Pain for me. Yeah,
Headache?
whatever. Headache. Yeah, but from me to you. In math, one of my jobs is to introduce all these really weird math symbols, and they all have meaning. Okay, especially meaning in context. So this is an aside. These absolute value symbols are not the same as a parenthesis. They're not the same as brackets. They're not the same as braces. All of these have special meaning to us in mathematics. And you need, as students, and I will teach you this and keep harping on it all semester long, but you need to use these symbols in the proper way. Okay, all of these symbols have special meaning in mathematics. Okay, and we need to use them. Right now, we're introducing the symbols for what's called the absolute value. Now, I like to think of these as super parentheses. Is it parenthesis or parentheses? ES or IS? Somebody who's better in English? Whatever. You guys get the idea.
SIS.
Is it SIS? Plural? SIS? All right. Fine. Whatever. Okay. Because you must do inside first. Remember, PEMDAS says do inside the grouping symbol. Do inside the grouping symbol. So in an absolute value problem, we're going to take the absolute value of 7 minus 10. Like that. Absolute value of 7 minus 10. Well, we have to do inside first. Okay. So you go off to your scratch paper, or you use your calculator, or you just use your brain. 7 take away 10 is negative 3. Okay. 7 take away 10, they cancel each other out. There's more negatives, so you got negative 3. But the key on absolute value is it takes whatever is inside and makes the answer positive. So we drop the absolute value, and the answer is just 3. So the answer to an absolute value is always positive. When something comes out of the absolute value, it comes out as a positive. But the key here was you have to work inside first. You have to simplify what's inside. That's the parentheses part. Simplify it, get negative 3. The absolute value of negative 3 is positive 3. Now, a lot of students get confused because if I give them this problem, absolute value of 11 minus 2, okay, we do what's inside first. 11 take away 2 is 9. So this is the absolute value of 9. And a lot of people think absolute value takes the opposite. A lot of people will say the answer is negative 9. Wrong, wrong, wrong. The absolute value takes whatever's inside and makes the answer positive. Since it was already positive 9, we just leave it as 9. The answer to an absolute value is always a positive number. If it starts positive, then it stays positive. We're happy. But if it starts negative, then it becomes positive.
I have a
Okay,
question.
sure, shoot.
And this was probably anyway. Okay, I'm going for it. Why did 7 with a negative 10, like, or minus 10, become negative 3, and then 11 minus 2 became a positive 9?
Well, because, okay,
Sorry.
okay, let's look at it on the number line. This is set, here's
Right.
0.
Okay.
Start at 11 and
Uh-huh.
come back up 2, back down 2.
You
On the number line, I'm at 9.
got it right. Okay.
Okay. This says, I'll finish the thought. I think you have it, but this says, okay, on the number line, we're going to start at 7,
Right.
and then we're going to subtract 10. Well, that's going to get us, if I take away 10, that's going to move us into the negative somewhere.
Okay. Thank you. That's right. Thank you.
Is that okay? No, that's okay. That's okay. Okay. Anybody else? Any other questions? Okay. Don't delude yourself into thinking the answer to an absolute value problem is always positive. Okay, let me show you what I'm talking about. Okay, what if we had negative 7 times the absolute value of 11 minus, well, let's say 15, something like that. So, do you guys want to try it? Take a second and see if you can get it. Why don't we do that? Take like 1 minute. Okay, so what I said over here for absolute value, it's a super parentheses. You must do what's inside. So the first thing we're going to do is this.
Oh.
The first thing we're going to do is this. So we get negative 7, absolute value, negative 4. Okay. But what does the absolute value do to a number? Turns it positive. Now, there's a subtlety here. There's a subtlety. Okay. One of the main themes that you're going to hear from me all semester long is mathematicians are lazy. We are totally lazy. Mathematicians, for some reason, we think it'll break our hand if we wrote a time symbol there. So we make up this rule that says anything jammed together automatically implies multiplication, because God forbid we have to write an extra dot. And that confuses the heck out of students because we have all of these implied rules that you're supposed to know. So again, mathematicians are lazy. We have all these secret, handshake rules, whatever. You can't do this, can't do that. Always ask me, get clarification from me. I don't want you to be lost. But anyway, there's a multiplication there. So this part of the problem becomes positive 4. So this is negative 7 secretly multiplying by or with a positive 4. Negative 28 is the answer. Okay. A lot of times, the point of this problem was twofold. One is the absolute value part of the problem is always positive. In the end, the absolute value part will always be positive. But other parts of the problem may make it negative in the end. But the absolute value portion of whatever arithmetic you're doing will always be positive. Other parts of the problem will turn it negative probably, or maybe. The other thing, never, ever, never distribute into an absolute value. Never, okay? It will screw you up literally 50% of the time, okay? Yesterday, I think I did a problem. Well, I don't want to do that. Suppose we had 3 parentheses, 5 minus 7. Parentheses, if you wanted to, you could distribute 5 times 3 is 15, minus 3 times 7 is 21, and you get -6. Now, you shouldn't, because according to PEMDAS, same problem, okay, you're supposed to do inside first. So this is 3 times -2, and you get -6. My point of this was, with a parenthesis, you can distribute into a parenthesis, and you should get the correct answer. But with an absolute value, you cannot distribute in. Literally 50% of the time, you'll get the answer wrong. And 50% is failing. So never distribute into an absolute value. Okay. That was section 1.3, opposites and absolute values. I want to go on, but anybody have any questions?
Could there ever be a possibility that the answer would be a negative number if it's within the absolute value?
No, that's no. When it comes out of the absolute value, when it goes from this step to this step, that has to be a positive. I'm trying to think of higher levels of math, and because the rules we tell you here, they get kind of tweaked and modified as you move up into higher, weirder stuff. No, that's an absolute. No pun intended. I'm sorry. The answer will always be a positive number to that part of the problem. Okay. Anybody else? Okay. Can I erase this?
I'm cool.
Okay.
Yeah. I'm
All
good
right.
here.
Yeah.
All right. In chapter, what was it? Chapter 1.6, we've already covered, people ask me these questions. It's add or subtract fractions. And people asked me a lot of these questions before class started, which is really good. Okay. The key is you must have what we call a common denominator. And in math, the word common means same. Okay, so the key is we have to have a common denominator. So when we had, I don't know, something like, 3/8 plus 5/6, something crazy like that. Or let's even make it a -5/6. Okay, we talked earlier, now we have 3 different ways you can do this problem, 4 different ways. One is you can say, you know what, screw all this stuff. I'm just going to go put it on my calculator. Okay, and again, we'll talk about using your calculator later. It's not that hard to do. But the other thing, the way you do this, method number 1, is you rack your brain and you go, okay, what number does 8 and 6 both go into? Okay, well, I see 24. So you say, okay, the common denominator was 24. So this would be multiply this by 3 and 3 to get to 24. And this will also be 24. So multiply this by 4 and 4. Okay, so this will become 9 over 24. This will become -20 over 24. The rule says keep the common denominator, 24, add or subtract the top numbers, 9 plus -20. Now, however you want to do that in your head or on your calculator or whatever, that's up to you. I'm not going to force you to do 9 plus negative 20 in any special way, as long as you get 11, negative 11.
Is
As
that a
long as you,
Is that
huh?
4? Is that correct? I can't right next to the negative 5/6.
That's a 4 over 4.
Okay. And how did we get that? I'm sorry.
Okay, this is from your head. This
Oh,
is
okay.
okay. Yeah,
Just a random number.
this is just, you knew your times tables and you start thinking, okay, what does 6 go into? What does 8 go into? And then you use your times tables to make them both equal 24.
Oh, okay, cool. Thank you.
Okay, that's the way we teach it in middle school, high school, whatever, whenever they teach fractions. They just make you think about what's the common denominator. Okay, that's why you learned all your stupid times tables. Okay, so this is negative 11 over 24. Okay, but the other way, the sophisticated way we talked about this, or actually, let's go for the less sophisticated way. Okay, the less sophisticated way is to say, you know what, screw it. I'm just going to multiply this by 6 and 6, and I'm going to multiply this by 8 and 8. Okay, I'm not even going to try for a lowest common denominator. I'm just going to do this. Use the other denominator. This becomes 18 over 48. This is negative 40 over 48. Whoops, 8. Come on. Okay, so this, I'm going to skip a step. 18 take away 40 is negative 22. Okay, over 48. And then if you reduce it, you get negative 11 over 24. Same answer we got here. Okay, so I don't care how you get it. And remember, I said you can also use your calculator. Okay, and I showed you an even more sophisticated way of doing a factorization of this. And I'm not going to bore you with that one right now. We're going to get enough of that when we hit chapter 5. That'll kill you there. So, but that's addition, subtraction of fractions. That was it. Okay, that's all there is. Just a quickie review. And you guys asked a lot of those questions before class started. So that was pretty cool. So me personally, again, we're moving through this as real quick review. I think we've reviewed it enough that you guys can attack the homework. But do you have any questions with adding or subtracting fractions? No?
So for the negative, it doesn't matter where you put it, top or bottom, right?
That
It
is
has to
correct.
be.
Yeah, sometimes you might run into some trouble with mom. Okay, sometimes she might, you have to read the directions very carefully. She might require you to put this as 11 over, oops, I'm sorry. Put the negative sign out in front. I haven't run across that yet, but sometimes she's a little idiosyncratic. Idiosyncratic? What's the word I'm looking for? The root word is idiot, so that's good. Never mind, I don't know. But sometimes she forces you to put it that way. Change it. You don't get penalized on the homework at all. So, all right, anybody else? Okay, then we're moving right along. Okay, I want to get chapter 1.7. Okay, and the key here that people struggle with is how to round decimal numbers. Okay, last night we talked about how to round whole numbers, and it was all based on place value. Okay, look, I'll be really honest with you. When a quiz comes, I might have one question that asks you to round a whole number. there might be 2 questions that ask you to round a decimal number, at least on the quizzes this half. When we get into the second half of the course, when we start doing some word problems in the second half of the course, there will be an instance where the problems tell you to round to the nearest 10th, round whatever. So first half of the course, rounding is kind of a nice topic, 1 or 2 questions at worst. Second half of the course, rounding is going to be more critical, especially when we hit word problems. Okay, to round decimals, okay, 3.14159, good enough. Okay. This place value was called the tenths. The reason you know you're in decimals, okay, because we put a THS at the end, tenths. Okay. Next place is hundredths. Again, it's got a THS. Next place is thousandths. And all of these are in the online text. So, if you don't get this and you want to go back and read the text. The next place is the 10 thousandths and the 100 thousandths. I'm not going to write that up here. But the 5 is in the 10 thousandths place. And the 9 is in the 100 thousandths place. Okay. Now, rounding decimals is a little bit different than rounding whole numbers. Let's say we took 3.14159 and I said round to the nearest thousandths. Okay, so just like we did last night, we identify who's in the thousandths place, the 1, that one. Tenths, hundredths, thousandths. We look immediately to the right, the digit to the right of that. And we ask, is that number big enough to round that up? The answer is yes. Okay, so it rounds up to a 2. Now, this is where things get weird. The 5 and the 9 drop off. They're not there. The rest of these stay whatever they were. You can't write 5 and 9, and you don't write zeros in their place. Last night, when they were whole numbers rounding, we put some zeros as placeholders. You don't do that. Okay. When we're rounding in decimals, you round the thousandths place, look to the right, and then everybody drops off. The 5 and the 9 are gone. That's the answer. Here's the key. When it says round to the thousandths, then your answer should only contain thousandths, tenths, hundreds, thousandths. If you put a 5 and a 9, or even if you put a zeros and zeros there, then you're using 10 thousandths and 100 thousandths. If it says round to the thousandths, then your answer can only have thousandths as a decimal right there. Okay. What if I had 3.798? Okay, this is a trick question. 3.798. And I said, I want you to round to the hundredths. Oops, I can't spell it. Hundredths. Take a second and see what you get. Don't shout out the answer yet. Round this to the hundredths is a trick question. Okay. Anybody want to offer or volunteer a possible answer?
I got
Is it
3.8.
3.800?
3.8. 3.8.
3.8. I heard 00. I have 3.8. Anybody else?
I said 3.80.
3.80. Okay, let's see what happens. Okay, one of those is correct. Round to the hundredths. That one's in the hundredths place. So we look to the right. Is the 8 big enough to kick that up? Yeah. But what's the only place the 9 can kick up to? A 10. So put down a 0, carry the 1, and we get 3.8. Now, the question is, what do we do with that 0? Do we drop it or do we
No.
keep it? Okay, we keep it because of what I said here. If your problem says round to the hundredths, then your answer has to be in hundredths. Okay. If you dropped it 3.8, that would be in tenths. If you kept the extra zeros there, that would be in thousandths. That would be 800 thousandths because of that extra 0. Because if it says round to the hundredths, then your answer can only be hundredths. So the only correct answer is 3.80. Yes or no to everybody? No? Yes? Maybe?
Yes.
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 Yeah, that makes
Yes.
sense.
Okay. So that's a thing that kind of fouls up students there a little bit. They get all confused. Well, I'll worry about place value later. That's rounding 1.7. That's the thing that screws up students the most, is rounding and rounding properly. By the way, you only round at the end of a problem. You're reading some stupid problem, blah, 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 and it says round to the nearest tenth. Well, you never round in the middle of your work, ever. Is that getting blurry or is that, well, I thought I fixed that. The black is in good focus, but the orange is pretty bad, isn't it?
I think it's just the orange marker.
I thought that was just your pen. That was
Okay. Yeah,
That's readable.
Okay. Well, if it's not, yell at me. Last semester, I bought a new camera that we're looking through.
It was great.
Actually, I didn't buy it. I should take that back. Somebody in the math said, hey, we've got a few cameras we'll loan out to you. Do you want it? And I said, yeah, I want it. But what happened was the camera had an autofocus. And you've noticed me walking backwards and forwards. And sometimes, it caused the camera to have basically a spaz attack. It didn't know, okay, do I focus on him when he's close? Do I focus on him when he's back here? Okay, so the camera was going in and out of focus, and then eventually it would just freeze up. It said, screw you, I can't figure out what's happening. So it just would freeze up. I'd have to shut the camera off or restart it. Well, I figured out eventually over the summer how to turn off the autofocus. And that was real fun because I had to unload the drivers that came with it, load in different, what a mess. But I think I've got it fixed so that it's staying focused on the board and not on me. But we'll see. If it ever goes out of focus, yell at me. It's okay. So we okay with rounding? You guys think you got a handle? You can go through and round it?
I think so.
True.
Yeah.
Okay, yeah.
Go.
Again, this
Yep.
is just mostly review. Okay. Mostly review here. Quick. In chapter 1.8, okay, they introduce some vocabulary that we actually covered last night. Okay, I'm going to start here with the real vocabulary. And when we talk about a real number, you'll hear that phrase a lot, a real number. That is every number on the number line. The real numbers are any number you can find on a number line. They're all the fractions. They're all the decimals. Okay. They're all the square roots. They're all the positives. They're all the negatives. Anything you can find on a number line is called a real number. Okay. The real numbers are divided into two major categories. The first category is called a rational number. And this is where we talked about it last night. And a rational number, the root word was ratio, which means fraction. So if a number can be expressed as a fraction, okay, then it's called a rational number. And we had things like 0.5, 0.3 repeating, okay, negative 3.7, something like that. These are all rational numbers because ultimately they can be expressed as a fraction. Now the thing, okay, 2.5, that could be a fraction, whatever, all these things. And we introduced concept of a terminating decimal. And a non-terminating but repeating, repeating. So 0.5 would be considered a terminating decimal. The decimal stops. Okay. 3.7 negative would be considered a terminating decimal because the decimal stops. 0.3 is a non-terminating, but it's repeating a pattern. Okay, so anything that fits into this category is called a rational number. And we're going to be using these quite a bit this semester, and I'll come back and review the vocabulary as we need it. But the opposite of rational is irrational. So the real numbers, these are all numbers that you can find on the number line somewhere. Okay, on the number line. First category is called the rational numbers. Oh, by the way, I should put this up here. For example, 6 is called a rational number. Why? Because you could write it as a fraction. You can call it like 12 over 2. It's 6. And its decimal is 0.0. It stops. It's terminating. So 6 belongs here. Irrational numbers are like the square root of 2. The fifth root, weird roots, the fifth root of 97, which we'll talk about later this semester. But weird roots, radicals. Square roots, most everybody kind of knows, but we have weird roots, also bizarre ones. Okay. Pi is called an irrational number. Some of you from science know a number called E, Euler's number. Okay. These are all irrational because the decimal goes on forever and there is no repeating pattern. So for these irrational numbers, and these are just a few of the examples, and we'll get a whole bunch more. Okay, their decimal version, even if you pop these into your calculator, the decimal goes on forever. Okay, and your calculator cuts it off because it hits the end of the screen. But it actually goes forever, the decimals for these things, and there's no pattern to them. And again, this will become something we'll talk about later this semester, but that's the basic ideas. Now, there's a big thing here. In a square root, now most of you have seen square roots before, like you've seen the square root of 4 is 2, okay? Or the square root of 64 is 8. Most of you have seen square roots before, okay? And on your calculator, it is capable of doing other ones. If you can figure out the cube root of, I don't know, 40. Can I do it? Let me see if I can figure it out. Where's my decimal? Oh, there it is. Turn it on. Boom. Turn it on. Stupid. Clear. Come on. Well, my calculator doesn't want to do it now. Why not? Second. It's putting something else up there. Well, I'm going to have to fix my calculator. Great. Okay. Anybody have that on their calculator? It should be something like 3 point, I'm going to say 5. 3 point what?
41995.
3.41995. I don't know why my calculator wasn't working, whatever. And remember, it goes on forever and ever, and it has no pattern. Okay, all of these are real numbers. All of these are real numbers. You can find all of these on the number line. But here's a catch. The square root of a negative number is not real. Okay? Try that on your calculator. Try and input the square root of -4 on your calculator. And you should get a big old giant error. Let me see if mine will do it now. If it won't, I'm in big trouble. Okay. What?
Yeah, see,
Why?
it says domain error.
Right. And I'll explain domain in a little bit. Boy, I managed to. Okay, I'm going to blame my grandkids because they come up here and they play with all my stuff. So I'll blame them. My calculator is really messed up. Yipes. Second. Okay. Okay. All right, I think I got that part fixed. Remember to input a negative on your calculator. You go the square root and you have to use the negative that's in parentheses for, but you're right, you get a domain error. And that's the calculator's way of trying to tell you a bunch of things, but mostly that it's not real. It's not a real number. Okay, so that's one thing you've got to kind of be aware of. Every once in a while, we'll throw a problem at you that doesn't have an answer. Okay, you should write not real, but if you could just say there's no answer to it, that's fine. But mom will try and trick you with that. So basically, square roots, okay, you can't have a negative number inside of a square root. You can't have a negative quantity inside of a square root. That's one major thing. There's another thing we worry about. And it's actually handled in chapter 1.9, but it's division by 0. Okay, this confuses the heck out of students. Okay, and the only answer is undefined. And mom actually is very consistent with that. You actually write the whole word undefined. It just plain doesn't make sense. Okay, let's go back to grade school. Yay for grade school. How did they, anybody remember how they first introduced the fraction to you? The 3 is the numerator, the 4 is the denominator, but what did they, how did they introduce it to you? What did it mean?
3 divided by 4.
No, that's not how they introduced it to you. Teacher stood up there and maybe they had a felt cloth or something like that.
3/4.
Yeah, well, what's it mean? Didn't anybody talk about a pizza?
That there's
Yes, I was gonna say
Oh,
a pie.
yeah.
Yeah,
I was
isn't
gonna
that
say
what
cakes
people
too.
do? Or pancake. Okay, there you go. So the 4 said we cut our pizza and our pancake into 4 equal parts. That's what the denominator says. How many parts do you have? And the 3 says, well, how many you got? You got to eat. 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 Okay. So you got to eat 3 of these. Didn't matter which 3, they were all equal parts. Okay. Sometimes they got really fancy and they said, ooh, we have a candy bar. Okay. And we're going to take 3/5 of a candy bar. So instead of the pizza, they went to a candy bar. So we go 1, 2, 3. Okay. So we have 1, 2, 3, 4. We have 5 equal parts. And we're going to eat 3 of them. We're going to eat this one, and this one. That's usually how people introduced fractions to students, at least at the beginning. Then we got all fancy and we went to decimals and we went to money and we did other things. Okay, so here's my first question to you. Does 0 out of 4 make sense? Use the pizza, okay, concept. What would that mean? 0 out of 4.
No pieces.
You have
eaten from
nothing?
the pizza.
You didn't get it.
Nobody's eating.
Well, no, this is you. This is you. So there's a piece of pizza. It was cut into 4 slices. And how much did you get?
Nothing.
None.
Zero.
Nothing. You got nothing. Is that possible? Yeah, that makes sense. Okay, especially if your friends are pigs or something like that. But that makes sense. Okay, and so from that, we get to the algebra or the arithmetic answer that whenever you have a 0 in the numerator of a fraction, the answer is 0. We just reduce it or simplify it to 0. 0 out of 4. We had 4, you got nothing, you still have nothing. That's the simplified answer. But now, here comes the fun stuff. Does this make sense?
Is it undefined?
Why?
You ain't got no pizza.
Yeah, that says there's no pizza. Okay, but you got 4 pieces of it. That's what that says. There's no pizza at all. Remember, the denominator tells you how many pieces. Well, there's no pieces. And the numerator tells you what you got to eat. 4 of them. Okay. No pizza. I ate 4 pieces. That makes no sense to me. And so in math, in all of algebra, we say undefined. Because it just doesn't make sense. Now, there's other more sophisticated ways of showing this, but that's the basic idea. 0 on top, the answer is 0. 0 on bottom, the answer is undefined. Okay, always. Okay, So what time is it? Okay, I got time to get a little bit further. So I want to move into chapter 2 a little bit, just a little bit, and then we'll quit early tonight again, but after I get through chapter 2 for a while. I personally think I've covered most, not all, but most of chapter 1. If we come back tomorrow night, I'm hoping you guys keep going on your homework and ask me some questions if you're stuck. Remember, this Sunday, there's a quiz on mom. Well, you could do it now for all that matters. There's a quiz on mom that asks you to practice inputting numbers, inputting answers, and you can redo that quiz as often as you want and get as high a score as you want. Okay, so I'm done with chapter 1. I want to get a little bit into chapter 2. I want to show you some stuff on Canvas, and then we will quit early tonight again. I know we're supposed to go to 9:10. I know you guys really want to learn a lot of math and you want to stay up to 9 o'clock or beyond, but darn it, we're just going to have to quit early tonight if I can get through this junk. I hope you're not too upset. Okay. Any questions on chapter 1?
I have a question.
Sure, shoot.
So for mom, are we supposed to write in the word undefined or do we put D and E?
What does mom want? I thought she wanted undefined, but does she use D and E?
I think D&E was used.
Okay, then
Yeah, I
then
think
D and E.
D&E.
Then I'm
Okay.
wrong. I'm confused. Then mom uses D and E. D and E stands for does not exist. So I'm wrong. Thank you for the clarification.
Thank you.
And by the way, it's good to see you in here.
I have a question.
Yeah.
Yeah. So going back to chapter 1.8 with the real numbers. So you said, was it split into rational numbers and irrational numbers, or was it
Yes.
one or the other?
No, those are our 2 main categories. The real numbers are split into 2 categories, just like human beings are split into males and females, but they're still all human. The real numbers are split into irrationals and rationals, but they're all called real.
Got it. Perfect. Thank you.
Okay, yeah. Anybody else? Anyone? Okay, where to go?
I'll
All right.
probably have some questions tomorrow.
That's fine. That's fine. And by the way, guys, I'm in and out during the day. The last couple of days I've been home just staring in front of my computer because I got all kinds of paperwork to do at the start of the semester. So I've been able to answer a lot of emails quickly. But if you send me an email saying I'm having trouble and you can explain it via an email, I'll answer that email even though we're not in class. That's okay with me. Sometimes I'll even write up a little example and scan it in and send it to you, if that seems to be a better way. So feel free to contact me or Ann. Ann, are you here yet or not? I guess she's not here tonight. I don't know. So where does she live? I don't think she lives in Normal Heights. She doesn't have a power outage. Oh, well. So please, I'm any way you can contact me, anything I can clarify, try it. I'll do that. All right, chapter 2. Chapter 2, I want to solve an equation. Now, I'm going to give you some steps, okay? For the worst possible case, a lot of the problems in the homework aren't as bad as this, but I'm going to teach tonight the worst possible case that we can run into. So the first thing we're going to do in solving the equation is we're going to distribute to remove any parentheses. Okay. Second thing, we're going to multiply no, let me back up. I'm sorry. If there are fractions or decimals, multiply all terms by LCD, least common denominator. Let me put a star on that, because tonight I'm not going to show that. I'll come back and revisit this tomorrow night. Well, I'll do more examples. Okay. Third, on, good spelling, on each side separately, combine like terms. Okay. Fourth, use addition or subtraction. I circled the addition subtraction just so it stands out. Okay. Use addition or subtraction to, now I'm going to say the word move. That's technically not a math word, but to move all variables to one side of the equal sign and all numbers to other side of the equal sign. And guys, you're taking notes, great. I'm going to give examples for all of these, so don't panic. Okay. Fifth, and this is the last one. Fifth, use multiplication or division to isolate the variable. Usually, because I have no imagination, the variable is X, but it could be anything you want. All right. So let me read this again to make sure you guys can check your notes, see if I got it. Step one says distribute to remove any parentheses. Okay. Step two is about fractions and decimals. Don't worry about it yet. It says if fractions or decimals, multiply all terms by the LCD. Step three, on each side separately, which I think I spelled wrong. Okay. Combine like terms. Now, we haven't talked about that, but we will in a minute. Fourth step, and in my opinion, this is the key step, the fourth step. Using only addition or subtraction, okay? Move all of your variables to one side of the equal sign and all of your just normal numbers to the other side of the equal sign. So using only addition or subtraction, move all your variables to one side and all your numbers to the other side of the equal sign. And fifth step, using only multiplication or division, isolate the variable. So here I go. Example. And again, I'm going to do more of this tomorrow night. So if you don't get it tonight, don't panic. Okay. 5 plus 2 parentheses 3x minus 1 close parentheses equals 7 parentheses x plus 4 plus 2x. Oh no, let's say minus 2x. Yeah, that'll be fun. Now this is worst case scenario. Worst case scenario. Okay. 90% of all the problems in MOM, 90% of anything I'm going to give you on a quiz or a test will not be as ugly as this. Okay. But my feeling is if we can get through this, then we can get through all the easy stuff. All right, so here we go. First step, distribute to remove parentheses. Okay. Okay, let me back up. A lot of people would want to go 5 plus 2 is 7. First step, distribute. You got to do these in order. So my first answer would be 5 plus 6x minus 2. Because I distributed, I did 2 times that and 2 times that, because that was an implied multiplication. Okay, equals 7x plus 28 minus 2x. Again, I distributed. Is that okay with everybody?
Yes.
Any questions or hesitation on anything there? All right. Now, there's no fractions and decimals, so I can skip step 2. Forget that. Tomorrow night, we'll worry about that. Okay. Third step, on each side separately, combine like terms. What that means is think of the equal sign as a bar. Okay. Can you make the left side simpler? Is there anything that could be combined together on the left side of this problem? Well, yeah.
5 and 2.
5 and 2. So I would say this is 6x plus 3. I've combined 5 and negative 2 or minus 2. So those are like terms. What about on the right side? Is there anything that can be combined there?
7x and 2x.
Yeah, 7x take away 2x. Like terms, that makes 5x equals 5x plus 28. Oh, this would be too nice of a problem. All right, so that's, excuse me. So I'm following, I distributed to remove parentheses. Okay, I combined like terms. Okay, now here's the key. Using only addition subtraction, I want to move all my variables to the same side, which means, for example, I've got 6x on the left, 5x on the right. I want to move them all on the same side. The typical way that people write this is they say, I'm going to take 5x away from this side. I'm going to subtract 5x from the right side. But I always have to keep my equation balanced. So if I take 5x away from this side, I have to take 5x away from this side. An equation represents balance. That equal sign says these things are balanced and you can't do anything to disrupt that balance. Okay, distributing doesn't disrupt the balance. Adding like terms doesn't disrupt the balance. But if you take 5 away from this side, 5x, man, you just screwed up the balance. You're out of balance. So you got to take 5x away from the other side to make it balanced again. Okay, so 6x take away 5x is 1x. And you don't need the 1. Those of you who know that, I'm just showing you 6 take away 5 is 1 equals 28. Because 5x take away 5x, they're gone. Is 0. There's no more x's on that side. Okay. Now, that's
Someone asked, why did we subtract 5x instead of 6x?
Because
Don't you want to work left to right instead of right to left?
Want to work with
no.
a negative number?
Let me answer that by not answering it yet. Let me come back to that question. That's a really good question. All we said over here in step 4 was get all your variables on one side. We didn't say which side. Doesn't matter in the end. But I heard somebody say this, what if I took 6x away from both sides? What if I did the 6x?
Negative numbers.
Then I'll have a negative answer. That's not wrong. I'll have a negative 1x right there. Not wrong, but I personally am leery of negatives. And if I can avoid negatives in the answer or in the problem, I will try and do that. But whoever asked the question, that's not wrong. It's just a different way to do it. And you would still get the same answer in the end. Your steps would be a little bit different, but you would get the same answer. I'll come back and do it that way real quick before I do a second example. But that's a really good question.
Oh, sure.
And the thing is I knew that if I took 6x's away from both sides, I'd get a negative x. And I just don't like negatives. Okay, so I arbitrarily decided to take 5x away from both sides because I knew, looking a step ahead, I knew that would give me 1x and I'd have a positive x, and I like positive x's better than I like negative x's. Okay, does that kind of answer the question or not? It's strictly arbitrary. You wouldn't be wrong if you did it the other way.
Yes, thank you.
Okay, so I'm down to here. Now, notice it said move your x's to one side and your numbers to the other side. So still using addition and subtraction. I've got to move all my numbers to the other side, which means who do I have to move? Who do I have to get rid of?
The 3 moved to the other side becomes
The 3.
negative. Negative
Yeah,
3.
so what's going to get rid of a +3? A -3. That's a plus. The only thing that wipes out a positive number is a negative number. It's opposite. But I have to keep it balanced again. Okay, always, if you subtract 3 from one side, you subtract 3 from the other side because you keep it balanced. Okay, we subtracted this 3 because we want to get rid of it. We wanted to move it out. We want to get rid of it. But we subtracted this 3 to keep that balance. So we're actually doing two different ideas here. So this gives us 1x equals 25. Most of you guys know that you don't need the 1 in front of the x anymore. So it's just 25. X is 25. Okay, now, well, I'm going to leave it like that for now. That's our solution to this problem. If I was a really good teacher, I'd make you guys take the 25 and plug it in for x here, here, and here, okay, and see, does the left side equal the right side? And the answer is yes, it does. Okay, a lot of teachers call this checking their work, show your check. And you do that by plugging the answer back up here, and you'll get an answer on the left, an answer on the right, and they'll be the same. I'm not going to make you do that. That's just nuts. All right, I want to do this a second time, but questions on it?
I have a quick question.
Sure.
So just how they were asking if you can do -6x instead of the -5x, can you do the same thing with 28 and do -28 minus 28 with the 3?
Yes. Yes.
And that would just be negative, right?
Say again, you cut out.
It would just be negative, right?
Well, and you'd have to get rid of the negative, and I'm going to do that right now.
Okay.
Yeah. Okay. Can I erase these 5 steps? Do you guys have them down, kind of, sort of?
Yeah.
Yeah.
Yep.
Yes.
Okay.
All good.
Okay. All right. So I'm going to do this problem, and I'm going to pick it up right from this step where we had 6x plus 3 equals 5x plus 28. Right there, same problem. But I decided to get rid of the 5x from both sides. What if I decided to get rid of the 6x from both sides? Okay, because that was the question, and it was a good question and a valid question. So 6x take away 6x is nothing, so we get 3 equals -1x plus 28. Well, look what I've done. I've moved all my X's to the right-hand side, which means I want to move my numbers to the left-hand side. So who do I have to get rid of? A 28. Do you guys understand the logic there? If I've moved my X's to the right-hand side, then I want to move my numbers to the other side. So I'm going to get rid of the 28, minus 28. Why was it a minus 28? Because that's a positive 28 or a plus 28. So the only thing that cancels out a plus 28 is a minus 28. But you have to do it to both sides. So we end up here with negative 25 equals negative 1x. Now, the key, this is not the answer. And if you left it like this, you'd get the problem wrong. The key is to get x completely by itself. Okay, you can't have this negative 1 in front of it. So we divide by negative 1. But we have to divide this side by negative 1. Because what happens with a negative divided by a negative? Well, that's a positive 1, and that positive 1 doesn't affect the problem. Most of us just say, hey, they cancel out and we don't care. Okay, but you have to get the x completely by itself, so you had to divide both sides by negative 1. So negative 25 divided by negative 1 is positive 25, and we got the same exact answer. Are we okay? That
Yes.
couple of you were asking that question. In the end, it doesn't matter. This one just required an extra step to get rid of the negative. Whatever. All right, I want to do one more of these. Anybody have a question before I put one more up?
I got a quick question. So you divided them by -1 because it really doesn't matter. Is that why?
I divided it by -1
To get rid of the 1.
to get rid of the negative. Look, let's say we'd done another problem. Okay, and you'd had 16 equals negative 2x. We did some other crazy problem. We did it all the way down and we got to this step. You want to get x by itself, totally by itself, but it's being multiplied by the -2. So the only thing that undoes or cancels out multiply by -2 is divide by -2. But you have to do the same thing to this side, divide by -2. So these on the right-hand side, the -2's just ultimately cancel each other out and you just get x. Okay, over here you have some arithmetic and you get -8. So what I use is whatever was in front of the x, that's what I divide by, because I know they'll cancel each other out.
Ah, got it.
Okay, now I didn't have to do it here because a 1 times x is just still x. Okay, I wish I'd come up with a harder problem. All right, you guys want to try one on your own, just see how you do, walk through tonight?
Sure.
Okay,
Yes, please.
Yeah.
all right, can I erase this alternate method over here?
Yes.
Yep. Yes.
No one's gonna yell at me, okay. Okay, somebody give me a number, any number.
3.
3. Plus, give me a number.
7.
7 times, give me a number. 2x plus or minus,
Plus.
Minus.
plus a number. Oh, I'm going to put 5 equals, give me a number.
6, 8,
6. 8x minus, I don't know.
22.
Oh,
Seriously.
who the F said 22?
That was me.
Fine, okay. Who was that? Wait a minute, who said
That was me. It was Monosith.
Okay, fine. Yeah, great. We'll put 22 in the problem.
Kick him out of class.
Okay. All right, so make sure you can read. It's 3 plus 7 parentheses 2x plus 5 equals 6 parentheses 8x minus 3 plus some idiot's 22. Okay, I'll pause the video. You guys give it a try. Give you about 2 minutes. Do not shout the answer out.
And by -1, it's equal to 1.
I was trying to come up with an ugly answer. I was hoping the 22
Perfect
apparently made
answer.
the thing come up nice. Okay, so I wanted an ugly answer because I wanted us to have to deal with fractions and decimals, but I didn't. So first thing I did was distribute the 7 into this quantity and the 6 into this quantity, and I got this step. And then I decided to combine like terms on each side separately. So 3 and 35 became 38. And the 18 and the 22, negative 18 and 22 became positive 4. So those would be my first couple steps. Is that all right with everybody?
Yep.
Yes.
Yeah.
Okay. Now we make a decision. I want to move my x's to one side and I want to move my numbers to the other side. Again, it's totally arbitrary what side you move the x's to. However, I know that if I take 14x away from both sides, I'll still have a positive x. And like I said, I prefer the positive x's. So my step would be to take 14x away from this side, get rid of it, take 14x away from this side, okay, for the balance. Is that okay with everybody? In the end, if we all get the same answer, then it doesn't matter. But do you accept my logic and you follow my work? That's the key.
Yes.
Yes.
All right. So these 14s cancel each other out. They're gone. I have 38 equals 48 take away 14 is 34. Is that right?
Yep.
X. Don't drop the X plus the 4. Now, what I've just done is I've moved all of my X's to the right-hand side. So I have 34 X's on the right-hand side, which means I want to move all of my normal numbers to the other side. So whatever side has my X's, my numbers go to the other side. Okay, which means I need to get rid of the 4. But it's a plus 4, so I'm going to minus 4. Okay, I minus 4 on this side to get rid of the 4. Why did I minus 4 on this side?
To keep it
Balance
balanced.
it out.
To keep it
To
balanced. Good, good. Several of you got that. Minus 4 here to get rid of it. Minus 4 here for the balance. Always the balance. So this gives me 34. 38 take away 4 is 34 equals 34x. Okay, so maybe I shouldn't make fun of the 22 because the 22 really helped this problem. Okay, I want to get rid of the 34 in front of the x, but because I know that it's multiplying, the thing that'll cancel out multiplication is division by 34. That's the only thing that'll get rid of the 34. If that's 34 times x, I have to divide by 34. But for balance, I have to also divide by 34. So this becomes 1, this becomes x, and I'm done. Yes or no?
Yes.
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 Okay. Now, tomorrow night, we're going to do more of these, and I will get fractional answers, and I will use that step 2, where we have to get rid of fractions, at least at the beginning. All right. I want to show something. Okay. Why can't I? There I am. Okay. All right, cool. Can everyone see my Canvas screen?
Yeah.
Yeah.
Everybody's got my Canvas screen? Cool. All right. Couple things I want to point out. In the modules. Come on, modules. There we go. Okay. let's come up here. Yesterday, I showed you all of these modules. Now you're looking at my screen, which is a little bit different than your screen. These things that have the green check marks have been published, and you guys should be able to see all of those on your own canvas. These things on my screen that have open circles, they're there for me, but you can't see them yet. Okay. I thought I published that one. Oh, well, I should have published it. I don't know what the hell I'm doing. But this morning, I published chapter 1, and you can look inside there and you'll see, number 1, there's a worksheet inside of the chapter 1-2 module. And I've put a link to last night's video right there. Sometime tonight, sometime tomorrow, whatever, I'll put another link. I'll add a new link into here for tonight's video. Okay. And for then tomorrow night's video. And I'll just keep adding these. And as long as the videos fit in chapter 1 or 2, they'll be here. So you'll always be able to come back and review, or if for some reason you had to leave early or were sick or something and you want to figure out what the heck we did one night, they'll all be here in whatever chapter we're studying. So all the videos, exactly what we did. If I did things right, okay, when you go to the video, I'm not going to waste your time. You can play with it. But when you go to the video, it should be closed captioned also. So if you can't understand my words, maybe you can see the closed captioning and that will be clearer to you. Whatever, that's up to you. So anyway, I wanted to point that. Yes, I'm sorry.
No, I said that's awesome that you have the videos for us. Thank you.
Yeah, and I'll do that all semester long. All semester long. Okay. Next thing I want to do, let's go home. Okay. Those of you who read all my scary garbage on my home screen, okay, down here at the end, okay, I said during the second week of the semester, there will be an assignment that will require you to drop or upload into Canvas a 3-page PDF document. Okay. On your, almost everybody has a smartphone. You can download, read all this, something called a PDF converter. And I've given you the list of several names right here. You can read this on your own. And what these do is they take a picture of whatever you're looking at and they save it into a format called PDF. Okay, PDF. When I grade your papers on Canvas, when you upload them to Canvas, I grade them, I make comments on them. I actually write on your papers. And then I send them back to you so you can see my comments, so you can learn from them, so you can question me and go, why did you take 3 points off here? Why did you do this? So I make all these comments on your papers. It's much, much easier if they're in PDF format. That's why I'm forcing this PDF. Now, again, it's free. You can download it to any smartphone in the world. Note here, if you have Notes in your iPhone, I believe Notes has its own built-in converter.
Yeah.
So if you can use that, you don't have to buy anything. There in the resource module, there's a video that explains how to use Cam Scanner, but they're all mostly the same. You have 2 weeks to do this assignment. Okay. 1 page has to be handwritten, and you don't have to write the full page. Just write a limerick, write your favorite poem, write your name 5 times. I don't care what you do. The next page has to be a page from any textbook at all, anything you want. Okay. 3rd page, some kind of drawing. Okay, whatever. Now, let me show you. You should be seeing, I hope. Do you guys see over in the corner here, something that says an upcoming assignment? No?
Yes.
Does it?
That's coming
Yes.
because nothing.
Yeah.
Yeah.
It says what? Say again?
It
says
says
coming
nothing
from-
next week.
Really? Well, there should be something. I'll double check on that. I'll make
I
sure
see the
that's
to-do
going.
list.
tonight.
Is that what you're referring to?
Maybe it's there.
It's the to-do list. It says welcome to Math 96X and then upload PDF. That's what I see on my to-do list. I think
Okay,
it's a feature,
it's
though.
there. Okay,
Mhm.
well, here it is. Anyway, I'm showing you my page, but it talks to you about what I want you to have in PDF. So go ahead and try that. You can do it as many times as you want. If you do it the first time and get full credit, cool, you're done. But if you do it the first time and screw up, I'll say, no, you screwed up, redo it. And you can keep resubmitting as many times as you want until you get full credit. Okay? So
there. It's under assignments. I can see it.
it's under assignments.
Yep, you click on assignments, it says upload PDF. You click on that and it's a submit assignment module.
Okay, so it's there under assignments. Thank you.
Yeah.
All right. I knew I wasn't nuts. Well, that's open for debate. Okay. So anyway, now you have 3 or 4 things you're doing. You're doing homework on mom. Okay, you're continuing that to the best of your ability. You have a quiz coming up that's due Sunday evening on mom, and you can take that quiz as many times as you want until Sunday evening. Okay, and that's a practice quiz just on inputting weird math symbols. And now you have this PDF upload. It's got to be one single file, but 3 pages long. Okay, and you have 2 weeks to kind of figure it out, ask me questions, get help from your neighbors, anybody else like that. So are we okay?
Yep.
So
right.
I have a question.
Yeah.
So with the PDF form, if I make myself close, so the first page should be anything you write. You should write
Well,
anything.
okay. Let me do it this way. I don't, as long as it's got 3 pages, I don't care who's first, second, and third.
Okay.
One of the pages should have something handwritten by you, maybe a math problem.
Okay.
Excuse me.
You should. So that should be anything you want to write about.
Yeah, just make sure it's dark and readable. That's what I'm worried about.
Okay.
Okay.
And then another page is any page from a textbook.
Any book, your favorite book.
Okay.
What is it? The Traveling Pants of the Yaya Sisters or something like that? Isn't that a book? I don't know. I've got science fiction books all up the yin yang. I would do something like that. You could use the Constitution, something that our senators and representatives haven't read recently, I think. Any page, anybody. You could, that what would be really cool is, what was that poem that young woman read at the inauguration? That was the most awesome thing I've seen in recent history. So, anything that you want to do, 3rd page is a drawing. It could be a stick drawing. It could be a silly thing. It could be a really intricate drawing. Just don't make it a porn drawing. I have to draw the line at that. Okay. I'm sorry. Can't do that. All right. Does that answer your question? Are we okay?
Yes.
Okay. Now, last thing, new share. Last thing I want to do tonight, and then we're done. Come on. Bad picture. There we go. Back to here. I want you to email me again. Okay. You're going to email me again. And what time is it? It's 8:20. So email, again, my email was lafoster@sdccd.edu before 9 o'clock tonight. This, in the subject, I want you to put the word attendance. But in the body of the letter, now this is going to be kind of weird. Okay. I want you to put your name and then your short name. Now let me explain that. Because just looking at it on the board up here, it makes no sense. Okay, so your name is your real name. Okay, you don't have to put the whole thing up there, just so I know who you are, so I can look at you on Canvas or whatever, know who I'm talking about. But some people have really, really, really long names. And I'm going to make up a name. I'm going to make up this name, Larry Hastings, that's me, Foster,
That's you.
Junior, the third. Okay, something crazy like that. Okay, that doesn't make sense, but don't worry about it. That's what would be in Canvas for me. Okay, when you look up your grade, the way my grading program works, I don't use Canvas, I don't use Mom, I have a whole separate grading program that's very, very safe. No one will ever see your grades. But you don't want to have to type in that whole thing. Okay, that would be crazy. Because if you made one little typo mistake, then my grading program wouldn't recognize you and say you don't exist. Okay, so when I say short name, I mean shorten your name down to something you want to be called that's short and easy to type in. Okay, so for me, probably I'd shorten it just to Larry Foster. Larry Foster. Okay, you can shorten your name to anything you want at all, just as long as you remember it. But that's the name that my grading program will remember. It won't remember your official Canvas name, your official school name. It'll remember your short name. It's the name that you want to be called. That's easy for you to type. Does that make sense to everybody?
Yes.
Yes.
Okay.
First
Yep.
and last name, Professor?
Pardon me?
First and last name?
Yeah. Yeah, first and last name. Yeah, only because somebody has feet 91 or something like that, and I don't know who the hell you are. Okay.
Oh, that's
So,
me. Yeah, I can.
well, yeah, but so something that would give me a clue, who are you? You know, your first name might be the same, your last name might be different. I don't know. Yeah, first and last name, somewhat like that. But some people don't go by their first name. Some people go by their middle name, which is cool. Yeah. So whatever. Yeah, I'd prefer a first and last name so I know who I'm looking at when I'm looking at grades. Is that okay with everybody?
Mhm.
Okay, so you're going to email me again before 9 o'clock. In the subject, you're going to write attendance again. You're going to give me your real name. Okay, and then you're going to give me some reasonable shortened name. That's it. Good night. See you tomorrow night. Bye-bye.
Cool. Have a good one.
Thank you.
Yeah.
All right,
thank you, Professor. Have a
Thank
good night.
you.
Okay,
Bye.
night-night.
Thank you,
Bye-bye,
Professor.
guys.
See you tomorrow.
Bye-bye.
Bye.
Mr. Foster,
I didn't do it.
what happened to Math 38?
What do you mean, Math 38? Oh, do I recognize you? Wait a minute. Richard?
Yes, I was in your.
Yeah, I remember that now. What happened to Math 38? Oh, state law outlawed it. We can only have one. We can only have one Math 38 in all of Mesa College.
Oh, okay.
It's a really crazy state law. They got rid of almost all lower division classes. They're even talking about getting rid of this class.
Oh,
So,
okay.
but bust your buns. Make sure we can pass this class.
Yes. That's why I wanted to take it this semester.
Yeah,
Already made it.
good for you.
Good
Awesome.
seeing you again. It's been like 3 years, I think, or something.
Yeah, Yeah, I'm glad you brought it up and reminded me. It has been a long time. I have to go back and look things up. But
But I'm glad
good
I'm
seeing.
in your class again.
Yep, I am glad you're here too.
Thank
That way all right, take care.
Have a good night.
You too. Bye-bye.
Hey, Mr. Foster,
Yes,
would you consider this class a prerequisite for college algebra?
absolute. Oh, absolute. Wait a minute. Yes.
Okay, perfect. I think I talked to you last year and we figured out this would be the correct class for me to be in. Because ultimately I'm just gonna need, I don't know if it's 116 or 115.
16.
Okay, perfect. Yay. See you tomorrow.
Yeah, this is a prerequisite. The cool thing about 116 is the more you learn here, there's a great deal of overlap between 96 and 116. So the more you learn here, the better you learn here, the easier the beginning of 116 will be. So really, do your best up here. Okay.
Do you teach 116?
No.
Damn.
I don't. Well,
Okay.
let me take that back. I haven't. There's been real talk across the department about shaking up teachers and having people teach things that they've never taught. Well, I take that back. That they haven't taught in a long time. I taught 116 years ago. So I don't know what they're going to be doing in the fall. But right now, they like me teaching Math 96. So that's where I'll be forever.
All right, awesome. I'll see you tomorrow. Thank you so much.
Okay, bye-bye.
Good night.
Jan or Laura? Okay. Laura, are you there?